This presentation is about ABS braking systems, and initially I'm going to be looking at the inductive type wheel speed sensor, just looking at its construction and operation. So we've got a diagram here of a brake disc and the hub, and you can see this toothed wheel. We're going to talk about that in a moment. And here is a sort of an image of a sensor, and you can see that it's usually positioned quite close to the back of the hub. I've got some images here. Let's move on. Of brake sensors actually in situ on a car. So you can see there's our brake disc. Now the wheel's been taken off, but you can see the arrow there indicates the location of the actual ABS wheel speed sensor. Some more images here, just so that you can see the location. In this one here, you can see that the drive shaft has been pulled out of the hub, and you can see that toothed wheel. And again, this is just another image on another vehicle. Just at the end of the drive shaft, roughly where the hub is, you can see the green arrow indicates where the toothed wheel is. Now that wheel is made of a ferrous metal, so basically it's iron, and we use iron because it will conduct magnetism, but that will all make sense in a moment when we look at the construction of the ABS inductive wheel speed sensor. Now I've got a diagram here. Unfortunately, where I've sort of blown it up, it's distorted slightly, but I'll show you another image that I've drawn on my phone actually, so it's not brilliant, but I wanted to show you this so you get an idea of what I'm trying to draw in a moment. So this represents the toothed wheel. As I say, that's made of a ferrous metal, so it's basically iron, and we have a permanent magnet, so pretty similar to the sort of fridge magnet type things that you might have on your fridge at home. So something, it's just a magnetic material, so it's a permanent magnet. And around that permanent magnet, you can just make out that there is a coil, a single continuous piece of wire wrapped around. So there's one end of the piece of wire, and there's the other end, and it's wrapped around that permanent magnet. And usually that will be encased in some kind of plastic to protect it. So you can't actually see the wires. Usually all you can see is the two connections, each end of that single piece of wire. Okay, so I drew this image on my phone, so I apologise for the quality, all right, but what I'm trying to draw here is the toothed ferrous wheel or iron wheel. An iron will conduct magnetism, that's why we use it. And here I've got my permanent magnet, so it's got a north pole and a south pole, and around that I'm going to wrap a single continuous piece of copper wire, and you can see both ends down here. Now the magnet will have a magnetic field around the outside of it, so that's what I'm drawing on here. And when the tooth of the ferrous wheel is close to the magnet, some of that magnetic field is drawn into the iron wheel, effectively making the magnet weaker. And then when the gap between the teeth lines up, then the magnetic field becomes stronger. So we're increasing and decreasing the strength of the magnetic field. So now I'm going to show you my homemade inductive sensor. I just wave a magnet over the top of a coil of wire, and you can see the voltage it generates displayed on the screen. So having looked at how the signal is generated, this, and you saw the image projected on the screen in the workshop of my homemade inductive sensor. This pattern that you're looking at here is a typical pattern that's generated on an inductive wheel speed sensor that you would see on an oscilloscope. So just look at some of the details here. On this side of the scale over here, you can see we're measuring in volts, and actually the oscilloscope is set to plus or minus 5 volts. So we've got 0 in the middle of the screen, and anywhere up is obviously plus 5 volts. So you can see we've got 1, 2, 3, 4, 5 volts. And anywhere below the 0 is minus 1, minus 2, minus 3, minus 4, minus 5 volts. So we've got 0, plus or minus 5 volts, showing in, that's the range that we can measure our voltage in. In terms of the time factor, so what we're looking at is how quickly the voltage generated by the magnet changes, and that's going to be determined by how quick that toothed wheel is moving in front of the magnet. So we need to have a time base, and at the moment, if you look up on the oscilloscope here, the time base, so per division, all right, is 200 milliseconds per division. So each division, let's start over here, we've got 1 division, 2, 3, 4, 5, and so on. And each one of those blocks, each one of those divisions, it represents 200 milliseconds. Now there are 1,000 milliseconds every second. So 200 milliseconds is 200 thousandths of a second, or basically that represents 0.2 of a second. And we can count how many times the voltage fluctuates within a specific period of time, and this is referred to as a frequency, and we can work out the wheel speed from this.